Do you remember random variables? So we talked about characteristics and variables before. A random variable is represents a characteristics of a possible numerical value from an uncertain event that is going to vary from person to person, item to item. So a random variable represents a characteristics from a population, and it's because it's going to be vary from the item to item from this for this population. It's called random. We have two types of random variables based on the values or the data related to these characteristics or variable. We have discrete random variable, which its values come from a counting process, meaning that you can count actually the outcome of this random variable. For example, the number of classes that you are taking. So that's for a population of students. That's a random variable. The number of classes that each student take can be different from each other, right? So that's a random variable. Why is it discrete? Because the number of classes can be only 0, 1, 2, 3. They cannot be 2.3. They cannot be 3.5. They cannot be 4.9, right? So it had to be complete integer number. It has to be discrete. That's why we call it discrete. And you can count them, right? So these are called discrete random variables. This is an opposed to the other type of random variables, which are called the continuous random variable. So for continuous random variables, they come from a characteristics that whose data you can actually measure and you cannot count. For example, the height of a person, the height of a student, the weight of a student. These are still is going to vary from person to person, student to student, but also the outcome of these variables are measures, and they are not necessarily a complete number. For example, the weight of a student could be 125.68, so it can have decimals. It doesn't have to be a discrete value. In this chapter, we're going to learn about the probability distribution for discrete random variable. A probability distribution for discrete random variable is just a listing of the mutually exclusive possibilities for the numerical outcomes of these random variables associated with the probability of them happening. Right, it would make more sense to you if we see an example. So let's see an example here. So this is a probability distribution of a random variable, a discrete random variable. The variable is number of classes that you take. So it is discrete because the outcome is a complete number. It has to be discrete. So for example, 2 classes, 3 classes, 4 classes, 5 classes. So this is for a specific example that they do not take other values, other classes. For example, he or she doesn't take 1 classes or 6 classes or more than 6 classes. And also in the second column, there is the probability associated with each of these outcomes. So we could actually add other values here, the values that are missing here. Well, the reason that they are missing because the probability is 0. So we could actually list all of the values. For example, there is no outcome of 6 here. So we could actually add 6 here and the probability of that would be 0. Or 7, it would be 0 again. Or 1, it would be 0. So for a specific problem, which it deals with a discrete random variable, a probability distribution is just a listing of the possibilities of the outcome of that random variable associated with also the probabilities that they have, the corresponding probabilities. So we have, for each outcome, we have its corresponding probabilities, as you see here. This list this is called the random, the probability distribution of a discrete random variable. One thing important about this is that the summation of the probabilities here, they should add up to 1, as you see here that it does. Let's see an example. For the following discrete probability distribution, find the probability that random variable x takes values between 2 and 4, including 2 and 4. This is the probability distribution. In the first column, you see the values of outcomes of different values of x, and in the second column, you see the corresponding probability values for x values. So please pause, find the solution to this problem. What is the probability that x takes a value between 2 and 4, including 2 and 4? What is the probability that x takes these values, 2, 3, and 4? And then come back to see the solution. All right, so let's see the solution. The first step that we need to do is find a, this value a. So to find this, we know that the summation of the probabilities would add up to 1. So this means a plus 2a plus 3a plus 4a should be equal to 1. And if we solve this equation for a is going to be equal to 0.1. So a is 0.1. Now that we have a, we can find the probability that x between 2 and 4, including 2 and 4, and that's going to be the summation of these values. We just have to replace a with 0.1. So it's going to be 2a plus 3a plus 4a is equal to 9a, and a is 0.1, so the probability is 0.9. Let's see an example of a discrete random variable for a probability distribution. Suppose we want to conduct an experiment, a simple experiment. We want to toss 2 coins, and we define the random variable x as the number of heads that we would get. So we can define and build this probability distribution table like here. We're going to put the values of the variable x in the first column and its corresponding probabilities in the second column. So let's conduct the experiment. There are 4 possible outcomes when you toss 2 coins. You can get 2 tails. Both of the coins become 2 tails. That means no heads at all. We can get a head, a tails, and a head. We could get a heads and a tail. Or we could get 2 heads. So there are only these 4 possibilities. All right. So if you look here, the possibilities for random variable x, the output, it would be either 0 heads, 1 head, or 2 head. We cannot have 3 heads, we cannot have -1 head, we cannot have 4 head, etc., etc. So there are only these possibilities. Okay, so the first one goes for the probability that x becomes 0. That's 1 out of 4, because this scenario where we get 0 head is associated with this scenario, which is 1 out of these 4 scenarios. 1, 2, 3, 4. So its probability is 1 out of 4, which is 25%. How many scenarios can we get 1 here? So these 2 scenarios, we can get a 1, and that's 2 out of 4. So it would be 50%. And in the last scenario, we get actually 2 heads, and that's 1 out of 4 possibilities. So its probability is 25%. We can actually plot this distribution. As you see here, the x-axis shows the outcome of random variable. We can get 0 heads with the probability of 25%. The y-axis shows the probability. And we can get 1 with the probability of 50% and 2 with the probability of 25%. So this is the probability distribution uh, graph of this example. Discrete random variables, the expected value or the central tendency. Here we want to talk about and define the concept of the expected value, which is also called the average or the weighted average or the mean of random variable, which is a central tendency, if you remember. So we already learned about these central tendency measures, including the average or the mean before, but here we want to extend that concept and definition into random variable. So it's going to be a little bit different, and you have to be careful not to confuse these two. So let's see how it works. The expected value or the mean of a discrete random variable or the weighted average can be computed using this formula. Mu is equal to the expected value. This is, we show it by E of x. So that's the expected value of random variable x. And it is just a multiplication of the value, different values that random variable x gets, multiplied by its corresponding probability, and then we have to sum them up. And that's going to give us the expected value, which also we call it the mean. And we show it by mu here, as we have had this experiment before. So let's see what is the difference, how these two definitions are different from what we had before. So let's see an example. Suppose that we have a group of students. We have, for example, Alex and Sarah and Margaret and Bob. Only 4 students. And we want to find the average weight of these students. So suppose WA is the weight of Alex, WAS is the weight of Sarah, W sub M is the weight of Margaret, and W sub B is the weight of Bob. So to find the average weight, I'm going to show it by mu. Average weight, mu of 8. What we do is we're just going to add these up, W of A plus W of Sarah plus W of Margaret plus plus weight of Bob divided by 4 because we have 4 students. What this 4 means? We have 4 students and the weights of the contribution of each student's weight for us is the same, right? Because for us each student is the same. The probability that we pick every student is the same. It's 1/4, right? If we want to randomly select a student here, what is the probability that we would pick Alex? It would be 1 out of 4, 25%. What is the probability that we would pick Margaret? That's 1 out of 4, 25%. So we can actually rewrite this as this. It would be Wi for I in our class. I'm going to call our class as a stat class. Stat. Wi in the index I is the students in this class. So Wi multiplied by 1/4. Right? This is how we can actually rewrite it. So, right. So here, if you look at this formula, it's kind of a little bit similar, except so here we have the weight of each students. If you consider weight as a random variable, so here we have the value of the x random variable. Here we multiply by 1/4 because the probability of each student is equal. It's 1/4. But here we actually have different probability for each value. So instead of just using 1/n, we use p of xi, specific to that probability for the value that we have. So you can using this, you can actually see how this formula or this concept of the average can be extended to random variable. Okay, so now let's see an example for finding the average or the expected value of a random variable. For our previous example that we have, we performed an experiment in which we tossed two coins and we defined x, the random variable, as the number of heads that we got, and we developed this probability distribution. So x can be 0 with a probability of 25%, x can be 1 with a probability of 50%, x can be 2 with a probability of 25%. So let's find the expected value of random variable x, or the expected value of the number of heads that we would get. So we're going to use this formula to do that. And that's 0 multiplied by, so it would be this. It would be the value of x, 0, multiplied by its corresponding probability, 0 multiplied by 25%. Then the next value, 1 multiplied by 50%, 1 multiplied by its probability. Then the next value, 2 multiplied by its probability, 25%. So if we multiply these together and then add them up, we're going to get the expected value. So the expected value of number of heads in this experiment is actually 1. On average, we would get 1. This is what it says. The expected value of number of heads that we would get in this experiment is 1. Now that we extended the concept of average or mean for a random variable and we call it expected value, why not actually also extend the concept of variance and standard deviation for a random variable, which is a measure of dispersion or variability. So we would define the variance for a random variable, a discrete random variable, using this formula. Sigma square, which is the variance for population, is equal to the summation of these multiplications. So first we're going to find for each value that variable x might take, we find the difference between that and the expected value, then we square it, and then we multiply it by the probability that random variable get that value. And then we're going to sum them up for all the values that we have. And a standard deviation is just a square root of variance. So it would be a square root of this. Here, ex is the expected value or the average of random variable. Xi is the outcome, the i's outcome, one of the outcome of random variable x. And p of xi is the probability that random variable x would get value xi. So if we go back to the formula for the variance that we learned before, it's a little bit similar to what we had here. So the one that we defined before was we would find the difference between xi and its average, mu, squared, then divided by n. Right? This is the formula for average that we learned before. Right? This is the formula. The expected value E of x is actually mu, right? We call it also mu, right? So this part is similar. The only difference here is that previously we used to divide it by n. Now we multiply it with p of xi. Well, this actually means that we could actually rewrite it like this. We can rewrite it like this. So that this part would be similar, exactly similar as we have here. So this part is similar to this part. And the only part that is going to be different is this part. Here we multiply it by 1 over n, and here we multiply it by probability of xi. Because each value have actually different probability. Each value for random variable x would occur with different probability. Unlike in this example here, which we which each value actually happened with the same probability of 1 over n. So you can see similarities in this process that we define here for the concept of variance and standard deviation for a random variable. So now that we learned about the concept of variance and standard deviation for random variable, for discrete random variable, let's do an example. We're going to continue using our previous example, which is tossing two coins, and x, the random variable, is defined as the number of heads that you would get in this experiment. If you recall, the expected value of this random variable that we computed was equal to 1. So we're going to use the formula for the standard deviation. The standard deviation, as you see here, is the square root of this summation. So we're going to find the difference between each value that random variable x gets minus its expected value, which is 1 here. Then we're going to square that, and finally we're going to multiply it by the probability that random variable x would get value xi. So let's go ahead and do this. To do this, we need to have xi and also probability of xi. So let's actually go back and refer to the probability distribution that we have. So in this table, it shows the different values of x, which is 0, 1, and 2, and the corresponding probability. So sigma here would be equal to a square root of the first value that x would get is 0, and it's going to get 0 with the probability of 25%. So that would be, according to the formula, would be 0 minus the expected value, which is 1. Then we square that value and multiply by the probability that x gets 0, which is 25%. Plus the next value. The next value that x would get is 1 with the probability of 50%. So that would be value 1 minus the expected value, which is 1. This comes from here. This 1 comes from the expected value. This 1 is also come from expected value. All right. And then we square this value and multiply it by the probability, which is 50%. So this is 50%. And plus the next value. The next value that random variable x would get is 2. And it's taking this 2 with the probability of 25%. So we're going to do that for that 2. 2 minus the expected value. What is expected value? That's 1. Again, this 1 comes from the expected value. That's expected value. And then we square this difference and multiply it by the probability that x would get 2, which is 25%. So that's 25%. So let's actually write and type see a typed version of this, which is much neater than this. So I'm going to erase all of this. So here we have computed the standard deviation is 0.707.